So yes, my name is Stefan Andersson. I work for ParTec, a German HPC company. And I'm going to talk today not about workflow, as most of you already done, but about the integration of the quantum computers and classical HPC system. Because before you do the workflow, you really have to get the integration up and running so you can do the recalculation you're interested in. The presentation is based on slides presented at the BOF at the supercomputing 2 weeks ago. And so the slides are basically a subset what we did present by Dr. Christian Michelsen from the Jülich Supercomputing Center, Jonathan Cohen, the CTO of Quantum Mechanics, and my two colleagues, Thomas Moschny and Mathias Pütz. So the current status, most quantum computer you buy today is done by selecting, you select the QPU you want to use, and you go to the vendor and ask for a big black box, basically. And then you run your codes, your quantum algorithms on that machine. The problem is getting that to interact with your HPC environment is not straightforward. It's not enough to simply put an Ethernet cable and connect those two. You have to do a lot of integration in order to those two systems to work together. And also, I guess most of us are coming out of an HPC environment, we have done a lot of development over the years, and by we, I mean the whole HPC community, in getting the system in the status we would like to, we want to have it. That means we have a health checker running, we are sure the nodes are up and running, we have a system environment, a software environment we are using, and integrating all this is not easy. Also, what is very seldom thought about is the security setup should match between those two systems. I'm going quite fast through the blocks here because we are, I'm also limited to the 5 minutes, so I'm trying to be. So our idea is to work together with a company called Quantum Machines. I mentioned Jonathan in the beginning, and they don't develop a QPU by themselves. They develop the control unit, which is attached and controlling the QPU, basically. You can think the QPU as being the memory system and the control unit being the CPU, making it all work together. So they are able to attach most of the common QPUs which are available on the market to the control unit. And that's the first step we also want to enable. We want the system you're buying to be component-based, meaning you can replace a component without having to replace the whole systems. You can use you should be able to use multiple GPUs in different architectures and leverage your existing HPC investment. That's what we mean by component one. And then we want to have a flexible QPU programming access. We don't want to abstract, we don't want to force you to abstract to a certain programming language. You should allow to be able to select the one you want to use. And very, very important in the phase we are at the moment, you should also be able to do hard programming optimization, meaning you should be able to go down to the very low level of the QPUs, like the pulse processor, and be able to program that by your own. So there shouldn't be we shouldn't select for you in the beginning what level you are programming on. Think about it, in the very beginning of HPC environment, there was a lot of effort in defining the whole BLAS algorithms. And think about being able to do this kind of BLAS research on a QPU level. Don't have to be the BLAS routines, I understand that, but meaning you can go down and work on the level you want to. and then be able to provide this information to higher level users. And then we want to have a tight integration with the HPC environment. You should be able to use the QPU and the HPC in an integrated environment. So how does it work? So from a QPU point of view, basically you see here, left-hand side, you have your high-performance computer. On the right-hand side, you have your black box quantum computers, the way it's done today. The first thing we want to do is to move the software from the black box to the high-performance computing system. There is enough of power on that side, so you don't really need to put nodes into the QPU's quantum computer to run it from there. So for the functional units, you will basically be left with the control unit and the QPU on the quantum computing side. And then the next step is on the high performance computing side, you will be able to run whatever language you want to use. And for Next Silicon, the low level access I talked about is done over QUAQ, pulse level access language. If you don't want to use it, you can still stay with your Qiskit level kind of programming and run it from there. From a hardware, from the HPC point of view, what you have to do is you take your classical HPC, you take your quantum computer, you take the control node network with all the control units you need. The control units talk over the radio frequency pulses with the QPU. And then you put a gateway node in between those two systems. The gateway node is able to talk to the HPC system and also to the quantum computer system. On the gateway node, we put a quantum scheduler into it, which can schedule the jobs coming in from the classical HPC onto the different QPUs. And we want to be able to scale it, so you don't have one gateway node, you can have 2K, depending on the size of your quantum system. And on that level, we also put the user authentication and authorization into it. So you make sure that only the users who should access the QPU at that level that time are able to do it. So the user would then do his normal S-batch. We are working with Slurm at the moment. That's not a hard limit, but there's a starting point for us. So the user would start with an S-batch on his login node. The Slurm control node takes the jobs, and depending on the selection of what the user did, assigns the certain gateway and scheduler, queue scheduler to this job. So it would look something like this. The red box would now symbolize, the red circle symbolize one job running with MPI communication between the compute nodes and kind of routing to the QPU from these nodes. The other nodes, in this case 1, 3, n minus 1, and n, wouldn't have access to the QPU 1 at that point in time. But in parallel, there could be a second job running, accessing a different QPU. And it's important to think about this. I heard a statement at the beginning or in the last session we had that we should think about the quantum computer as an accelerator. But you have to think one step further on. From a quantum computer point of view, the HPC is an accelerator. So he can take certain algorithms, certain mathematical operations like the error correction and optimize it for the quantum computer. Okay. So the outlook for us at the moment, we have 2 projects going on, one with the Forschungszentrum Jülich, where we are getting up a demo system at the Cryo Quantum Computing Lab. And we are also working with Quantum Machine and other partners at the INKI project, where we will have a system with an HPC cluster and 3 different QPU assigned to it. There is a link I will provide with the presentation where you can read a little bit more about it. So, thank you.